Hello everyone, welcome back to Google Cloud OnBoard. I hope you have had some coffee and you are as excited as I am for our last module of the day. My name is Henry Wu. I'm a customer engineer for Google Cloud. In this module, I'm going to talk about compute. And as well as at any time during the session, if you have any questions, please feel free to leave your questions on our platform. And we have a team standing by to answer them. So let's talk about questions. Thank you so much for your participation. I actually have a great questions that coming to you, coming to me. So I'm just answer several of them. So the first question I have is around stack driver notifications. The question is, can the alerting notification be integrated with external tools like CA service desk, BNC, etc.? If yes, is there any documentation? Yeah, of course. If you want to look more about stack driver documentation, you can take a look at the stack driver. You can search the stack driver notification and search the keyword channel. You can have more information there. But for me, integrating with external system definitely workable. You can use webhook to achieve that. Second question is around Bucket object versioning. Great question. Okay, so you have already seen what you look like when you enable the versioning, and you can see two options or more versions in one bucket. So the question is, would the space be double? What about the pricing? So yes, so for bucket and object, if it's enable versioning, then each non-current version of an object is charged at the same as the live version as well. So make sure you enable them whenever you necessarily need it for your backup or monitoring purposes. So let's jump right into the compute parts. Here we also have four sections. The first, I'm going to talk about containers. The second, I'm going to talk about cloud functions. And later on, I'm going to talk about App Engine, and finally, Cloud Run. So I believe you already very familiar or already want to start using containers. So what does it exactly mean? Container-based virtualization is an alternative solution to a hardware virtualization, which is the traditional VM that we all know. The VM has a great benefit of isolating each resources because it has its own instance of operation systems. But having those isolation also, in the traditional virtualization world, it sometimes will be too slow to boot those instances, and it could be very resource heavy for those instances to run, and especially for the hypervisor underneath those VMs. Container, on the other hand, provides the modern operation system building capability to isolate those environments. So it can start much faster than the virtual machine and using fewer resources, because it does not need an operation system for each of the container to run the application. Instead, developer configure each of the containers with a minimum set of software library that it needs to do the job. And also there is a lightweight container runtime that does the job of plumbing the job and putting all the resources that allow the container to run, to launch and run. So next, let's talk about how you can deploy your application. For me personally, I've been practicing Scrum and DevOps a lot. I'm a Scrum Master, and personally, I love this part a lot because DevOps really can help your organization innovate faster and ship good features and innovative and have a better application delivered. So when we talk about how you ship your application, we're most likely we will talk about CI/CD pipeline. So what does the CI/CD pipeline really mean? CI stands for continuous integration. It is a developer workflow. So it looks like this. Let's say I'm working on a product, and as a developer, first thing I want to do is I want to pull code from a single source of truth. In that case, that will be some repository. So there is a repository, and I am a developer. I want to do some change. So the first thing I would do is I will pull those code requests from the repository and then start doing my application development. So the first tool you will need is to set up a source code repository. In this case, at Google Cloud, you can use Google Cloud Source Repository, or you can even use GitHub if you have any, if you are using third-party or open source projects. And the first thing when I come doing some code, the next thing I would do is, so as a developer, after I finish my code development, I might want to check in to the repository again to see what it look like in the environment. So the next thing a developer will do is they will commit their changes into the branch. And at this time, they are not directly committing to a master branch. Instead, they are working on something we call a feature branch, which is this branch is supposed to be isolated from the mass branch, and we will test it out, the feature in this branch. When the developer committing their code to the feature branch, then the next step, we call it build. What does it mean? So build phase, literally just putting the image, the container image in needs for these applications. It can be, there are several tools that you can use in the build phase. Could be Spinnaker or Google Cloud Build. In this case, Spinnaker will put in the application image and then build it and then store the artifacts of the application into some place like container registry. So once it's built, then the next step, you should start thinking about how you can deploy to your environment. So now we have a code committed to a feature branch, and we have a build engine, like already built image for us and stored it into a container registry as an artifact. The next step I want to do is I want to deploy to develop environments. How to do that? By deploying to the environment, you can use like Spinnaker or use if you need other resources like deployment, you can use Spinnaker or Cloud Build. If you need other resources, sometimes application is not just run by itself. Sometimes need other resources such as Google Cloud Storage, such as data store or pub/sub topic. At this point, you can use another service such as Deployment Manager to help you spin up those resources and manage them for you. So once you get it all in place, you start shipping your application to the development environment. And in the development environment, developer will start looking at what you look like in the real environment. And the reason we separate the development environment for your production and other environment is because you can do some tests in these environments. So in this case, once I deploy to develop an environment, and then I can do some automatic testing to verify my code to see if my feature is running properly, if all the tests is running okay. So one is all done. One is once you successfully verify your code, then you can consider merging your code change into the master branch. So that's the workflow. So first, the developer working on something, then pull from the master, and then start the coding. After they finish coding, they commit again, and then the build machine will build in a container image and then store it in the storage as an artifact. And then the deployment machine, such as Cloud Build or a Spinnaker, will pick up those artifacts and deploy to your environment that you want it to ship to. That's the CI process. What about CD? CD stands for continuous delivery. It is a workflow that is triggered when there is a change that put into the master repository. So they pick up to where continuing integration left, and start working on the master branch only. And for the CD process, the initial phase actually pretty similar. So you're also working with a source code repository, and you're also using some build tools such as Cloud Build or Jenkins, Circle CI, etc., to build your application. So once it's all built, you have your artifact. The next thing you will do is that you will deploy into a staging environment. So the staging environment is pretty similar to an environment, to a production environment. It's just, this is it's a safe place for you to test out the features that will probably be rolled out later in the production. So in the staging environment, you should start to run some integration testing. Because the environment is similar, you should test out if the other dependencies are well connected, and also you should run the performance testing that I mentioned earlier. When this all passed, when the all test has passed, then you can tag this build as a release candidate. So meaning that, this already passed the performance test, integration test, and this image is ready to go. At this point, you might manually approve those release, or you can build automatic a pipeline to do so. Once you trigger the approval, once approval is done, then the next step will be triggered, which is deployment to the production environments. So at this point, for deploying to the production environment, you should consider two ways to do so. The first is Canary. The second is blue-green release, depends on your strategy. And you should, once it's deployed, the final thing I think is the most important thing is that your job doesn't stop there. It doesn't stop when you finish the deployment. You should continue monitoring your service using the tools such as Stackdriver to make sure that your application running smoothly on the environment. And if there is, if it goes well, then you should continue monitoring and let it keep running. But if there is something wrong, something happens, you discover, then you should have the ability to roll it back to the latest stable release. So this is what it looks like for a CI/CD pipeline. In Google Cloud, we have solution around this to help you ship your container image fastly, and also help you to manage your pipeline easier by using tools such as Cloud Build and Deployment Manager. So just to recap a little bit again of what I just mentioned, a container image is a complete package that contains the application binary and all the application that is required for the application to run. When you deploy the same application image to your environment, to let's say you want to deploy to development or test or production environment, the benefits of using container is that it will make sure your application will perform exactly the same way in each of the environments. So here I'm going to just talk about a little bit more about Cloud Build. Cloud Build is a fully managed service that enables you to set up the build pipelines. That could be from creating the Docker image to deploy the image to a cloud container registry. And you can set up different steps in between. The good thing about using Cloud Build is that you do not need to download all the build tools or container image in your local machine. It will all manage it for you and build the image that you want for your applications. The next step is that when you are setting up all the Cloud Build in place, how do you start? To start, you can simply creating a build configuration file that specifies each step in your build pipeline. So the steps are pretty similar to commands. You can just tell your build engine what do you want them to do, what do you want them to execute in the build pipeline for your applications. And as you can see in the YAML file here, this is the configuration file as example. You can specify the name of the Docker image and put in some arguments for them to run this image. And you also can specify give the different tags to tab what does this pipeline mean and what is the result of this build process. The build configuration can be specified in YAML or JSON format. So let's talk a little bit more about deployment manager. So as I said, your application is not just application itself. It has much more. You probably need storage. You probably need databases. You need a network to be set up for those instances. And that's where deployment manager comes in. Deployment manager really enables you to launch the VM instance or the resource that you need for your build pipeline. So let's say you have an application that requires different kind of stuff. You can put it into a deployment configuration. And the deployment configuration, what it looks like, as you can see in the screen, it has 3 components. First component is the name. So you should give it a name. How do you want to call it about these resources? The second is type, meaning which type of resource you want to use. You want to use a VM, maybe a data store, etc. And the third is a property. It's like specify the spec of the resource that you give it to. And you can declare all the resources in the top level configuration file and just in one file, if it is simple enough for you to put in one file. What if your configuration is really complex? It's difficult for you to put all the configuration in one file. So at this point, you can consider using template. So deployment manager also allows you to create template so you can reuse it and create a subset of the configuration. And for the more complex scenario, you can import one or more template to construct your complete configurations. These deployment manager will expand this template and create a final configuration for you. Because for the ease of writing the configuration, deployment manager is designed for you to develop using Jinja and Python syntax. And then later on, Python will generate the YAML file for you. There are also some following features about deployment manager. First is that you can reuse the template and configure resources for different environments. Let's say if you have a test and a production environment, you can simply using the same deployment configuration with different properties. So really save you a lot of time. You just give in the different variables, different property, and the same template can be run in different environments. Second is that, let's say if you have a complex deployment, you can specify the dependency between each resources. For example, if you are creating a VM, and you need to depend on persistent disk to be created before the creation of the VM, you can set up a dependency between these two. So deployment manager will make sure that your following dependency is created before you do the action. The third feature is about startup scripts. We all have a lot of configuration, we want to put it into our VMs. At this point, you can specify a startup script that when a new VM is launched, they will automatically download the script and then run the software or the command that configure in those VMs. Finally, we're talking about output. So deployment manager allows you to define the output. What could it be beneficial? Let's say you are deploying a database and you want to expose the IP for other resources to use. And then in this case, you can declare the expose of the IP as an output. So other resources around it can use those IP and then connect to those databases. Just to summarize, why are we using container here? First, container gives us consistency. No matter what language you're using, which platform are you choosing, when you put in the container, it gives you the same environment for you to run and ship it to different, like either development, testing, or production environments. Second is loosely coupling. When you are developing using containers, it gives you a good isolation. So you can start thinking about how you design those loose couple in a microservice architecture. Third is workload. So as I just mentioned, because container give you a good isolation and it runs the same no matter which environment you run, so it's also easier for you if you want to migrate your workload from one environment to another. That could be from on-prem to cloud environments to different providers as well. Finally is agility. Once you have the container in place and you set up the CI/CD pipeline, you can deploy and ship your feature much faster. So to really give you the agility to see what is the feature, how users feel like the feature, and then they will send you the feedback as quick as possible. So it's at a positive circle for you to keep improving your application and give you agility. So by now, you should see a pop-up on the platform asking a few questions. There are 2 questions I started here. Please take some time to finish those questions, and we will discuss it at the end of this module. So next, I'm going to talk about event-driven processing. So let's say your application have many events. If there is only one event in your application, that's probably not a system. It's more like a function or a script. Okay, let's say you have so many events that could be internal or external, and those events could be uploading a files to a storage bucket, will publish a message using a pop-up topic, etc. And you might also have some external events, such as committing when you are trying to monitoring the code commit. Then you can adding another event that monitoring the commit process. Whenever there is a new code that commit to, let's say, the GitHub repository, you can create a webhook and then getting back to your system. For this type of events, you might want to have something that is capable to respond in those instances. You could later on processing by coding the other API, or just simply writing those data to a database, for example. And here we are talking about Cloud Function, right? Because Cloud Function really enable to achieve the event-driven and serverless functionality. So let's say I am a developer, and I am also, and I really like to travel, to be honest. But every time when I go to a foreign country, I found it super difficult to understand the menu. I don't know what to order because I couldn't understand them. So as a developer, I decided to build a system, to help me do that. And this is what it looked like if I try to build a system like this using the event-driven service. So the first step, when I go into the restaurant and I see the menu, I don't know what's going on there. So I take a picture. And the first thing I do is I upload my image to the system. And the system then upload those images to your platform. So So I have, in this case, I created a cloud bucket for this to store those uploaded image. And then, once I have those image, the next thing I would do is I want to create my first function to handle this tags. This is a cloud function I am going to use, and in here I'm going to call another APIs here because the purpose is I want to know what's written in this image, right? So the next service I want to do is I want to call a OCR service by calling our Cloud Vision API. So I believe you already seen the amazing demo from Han and Yifi about Cloud Vision API. But actually, Vision API also have more feature for that. So in this case, I'm using the OCR feature, which is optical character recognition features. Then OCR, the Cloud Vision API, will detect the task in this image and return it back to me. So the next step I want to do is I'm going to create a pops-up topic and to use the cloud function as a hook to trigger the next pops-up topic. So the next thing I want to do is, since I got all the tasks, I would like to translate them, right? So as you all know, Google is very famous for its Google translation service. And Google is also open those APIs to the public. So if you want to do translation, you can actually leverage the Google Translation API, and it's in Google Cloud. So here I'm going to call another API, Google Translation API, and I translate the text for me. So here I have another pops-up topic to subscribe to those tasks, and then writing back to my buckets as a translated files. So this is what it looked like as a process if I want to build a simple application. And as you can see in this architecture, you see all of the service I use is serverless function, and it allows me to only focus on the code development itself. I don't need to manage any infrastructure, and just need to focus on the code and see what's the results. There are more use cases. For example, you can set up webhook. It could be like coding HTTP calls whenever there is a new request sending in to your GitHub repository, or even just sending uploading image. This kind of event, you can create a webhook and using Cloud Function to process those events. The second scenario is that you can consider using it as a lightweight ATL. For example, if you have a text file and you want to transform the format a little bit to store it as a CSV file, for example, you can do that in Cloud Function. Finally is IoT scenarios. So we all have, so in the IoT scenario, there's a device keeps sending in data. So in this case, you can use PubSub to process those IoT streaming data, and then later on use Cloud Function to handle those application message piece by piece. There are two types of operation you can do in Cloud Function, asynchronously or synchronously. For asynchronous operation, we call it backend. We call it backend functions. So asynchronous, so these are type of scenarios that you can have here. So let's say if you have cloud storage and you want to have a hook after there is an object create, object delete, or object update. You can do that by using a background function in the Cloud Function, and then it will attach to those events and then start the event, start the processing later on. The second thing you can connect to is PubSub. So let's say you are importing logs from Stackdriver loading. You can have a Cloud Function that subscribe to the PubSub and to do later on processing. The final, the third example here is Firebase. Of course, if Firebase already integrated together, So you can also subscribe to those Firebase events as well. On the other hand of example here is we call it HTTP functions. So these are the synchronous function compared to the asynchronous function, which is a backend function. So HTTP function can be invoked directly calling the HTTP request. So it has basically you can just serve a request and give in a response. It has a default timeout around 60 seconds. So you need to ensure that the function will be completed, complete its execution before the timeout. And also need to keep in mind that to make sure that you need to return a response in time, so to avoid the negativity user experience. So how do you write your Google function jobs? As I said, there are two types, right? Background function and HTTP function. In short, cloud function can be written in Node.js function. And you can specify your function in an index.js file. And you can, for the background function, there are two inputs. There are event input and callback parameters. So if you want to write a background function, you can specify what is the event that will be triggered this function, what is a callback after the process. Same as HTTP function is also written in Node.js. You can specify your function in index.js. And there are also two parameters here. One is request, the other is response. So as I just mentioned, it can be served as a synchronous request and response job. So whenever there is a request, you deal with the request and give in a response. Note that because we have a package management system in place, so you don't need to upload your zip file of the package in dependency. You can just simply specify what dependency you want to use in the package.json file. And Cloud Function will automatically install those dependencies for you before it runs. And also, if you want to write some temporal file in your environment, you can do so. But just make sure Cloud Function do provide you a small amount of local storage. It will be located in the /temp folder. But when you write into those storage, make sure that you clean up after usage, because those temporary file actually is using up your memory. So those template files will be stored in the Cloud Function, as well as all the other process need to be taken in the memory. So make sure you clean it up before you finish the task. So next, I'm going to talk about deploy. You can deploy your function from either local machine or using Google Cloud platforms. From the local machine, you can use gcloud commands. And the gcloud command will automatically zip those source code files, upload it into the cloud storage, and then staging and put it in the bucket, and then ship it to the environment. And also, you can deploy your code directly from an independent source code repository. And also, if you are using other third-party repositories such as GitHub or Bitbucket, you can also synchronize your Bitbucket and GitHub repository to your source repository, and you can sync and deploy your code from there. When it comes to logging, you can simply, just as the same way as you normally do your JavaScript application, you can view your output of your console.log file or console.arrow file directly in Stackdriver logging. It's already integrated. Stackdriver logging will collect those logs from the application side and then integrate it into the platform. So you can just see and analyze your log from there. if you code through some errors, some uncaught errors, Cloud Function will automatically capture these errors as well, and then you can be viewed in Stackdriver error reporting as well. Make sure, as I just mentioned, you should put some metrics in your system. So in your Stackdriver, so you can make sure that the number of the invocation, the execution time, and even the memory usage of the function is well captured in the Stackdriver platform. So next, let's talk about App Engine. App Engine is an excellent option for you to deploy web application, your backend mobile application, HTTP APIs, etc. There are two environments in App Engine. First is standard environment. The second is flexible environment. The standard environment supports the latest stable version of the most popular programming language that's shown in the graph here. Flexible environment support you run your customer Docker image or some native runtimes as well. And you can use the Google Cloud Client library to programmatically interact with other services in Google Cloud when you are deploying an App Engine application. App Engine standard environments really good. Give you a good starting point if you want to start something really quickly, and it gives you some default machine type to choose from as well. Whereas in the flexible environment, it gives you more ability to customize your settings. And even you can have the ability to SSH into a VM instance underlying in the App Engine environment. And you can request for the root access as well for those VM instance. Because App Engine flexible environment is using the container image, so if needed, you can actually ship your Docker image to other compute environments such as Kubernetes Engine as well. This is another architecture of how you can think of using App Engine to deploy the microservice applications. In the chart, you will see there are two services. We have a front-end service, it's a web UI, and we have a back-end service that serves as NLP jobs. So in the front-end service, there are three pages. First page is a question page. So let's say this app is a quiz app, for people to create quiz and then add other people to answer those quiz, and those quiz will be analyzed, will be processed in our backend, and then sending back to our front end to see who is the leader, who performs well. So in this architecture, you can see how you can design it. Is that first you have the 3 pages that you can do that for sure, and in that you can connect your App Engine instance to other resources such as data flow and storage. So in there, you will be your question you created will be saved there, and when other people trying to take those questions, they can enter to those to that client page, and then input their question answer there. So when they input their question, their answer, then there is another pops-up topic that will be triggered from the client page, and that pops-up topic will later on trigger my other backend service here. So in this case, I'm using another backend service to respond to the NLP, to do the NLP job. And then once I got the insight, I store it back to the cloud spanner, and then display my result to the front end again. So how do you deploy? Actually, in the App Engine environment, it's super easy. This is the only line you need to remember. It's gcloud space as app space deploy. Very easy, gcloud app deploy. So it's you can deploy to different environment. If you have testing, staging, production, you can have one of the environment in each for one project in each of the environments, and can deploy to those projects. And to run this command, when you run this command, App Engine will actually pick up the source code and put it into cloud storage, and then build a Docker image, and then push it into a registry, and then going online for front-facing instance. Also, App Engine also automatically enable the load balancer for you, and runs your application in 3 zones. So it enables you to always keep your application always up and running. And the App Engine backend also auto scales. So you can scale your backend, so it will be scale up if there's more traffic coming in, or scale down to 0 if there's no traffic. You can set up, other service for, if you need some other service. Actually, there are a lot of service already integrated with App Engine. For example, the monitoring, logging, error reporting, health check, and SSL. So if you want to use those advanced features, it's already including there, so you don't need to worry about re-implement it again. So let's look at some deployment. So in App Engine, it actually enables you to perform the canary testing. Canary testing simply means that you can split the traffic and between these 2 experiments, so 2 environments, and then to see which environment performs better. And then once you confirm which features or which experience is better, then you can migrate the traffic into one specific version without any downtimes. For the App Engine flexible environment, it's very ideal for you to host those highly scalable and need to have highly compute-powered web-facing application. And it's based on the HTTP request and response, and you can deploy some public endpoints. And of course, if you already have a CI/CD pipeline in place, you can integrate your CI/CD pipeline with the App Engine here. So you can deploy directly to the App Engine as well. So there are 2 options in App Engine. First is standard, and the other is flexible environments. So how to choose between them? So let's say if you have like spiky or low traffic, then you should consider using standard because it gives you some default machine type you can choose from. It's much easier for you to just set up from there, and everything will be taken care by the App Engine. But it has some constraints that you only need to use the App Engine standard API. So it has some constraint. You need to use that to leverage other resources. Otherwise, on the other hand, in the App Engine flexible environments, it's much flexible, and you can customize your machine type, and then you can use the Google Cloud Client library, which give you the more ability to leverage other resources as well. And as I just mentioned, if you need more settings, more configuration needed, you can move your containers to other compute environments such as Kubernetes, Compute Engine, or other platforms as well. So there are some scenarios that you should consider not using App Engine. So the first is that if you need other protocols other than HTTPS, because App Engine supports you to connect to people to connect to your application using HTTP and HTTPS protocol. But if you need something other than that, then you should consider using other environments. Second, if you want to use persistent disk, then you need to have the VM, for example, to really attach the persistent disk for you. In App Engine, you are not allowed to do that. Third, if your traffic is more spiky and have low traffic, then you should consider using something like Cloud Function or Compute Engine preemptible type of VMs to handle those traffic for you. So I talk a lot about App Engine. Let's take a look at the demo to see what it looks like when I really deploy an application to Google Cloud Console. Cool. Let's jump right into my environment here. So as you can see, this is the other application, actually the same application, but I deployed to a different project. So if you click into it, it's the same guestbook API, guestbook application I just create. So I can just type something here, say still working. Cool, so seems like it's working. So the next thing I'm gonna do is that, okay, but it looks too similar, so I want to do some modification. I want to make a guestbook 2.0, for example. So here I'm gonna to just change a little bit of my code, and hopefully I will get better feedback from my user for my guestbook 2.0. So let's just open my Cloud Shell here. Cloud Shell is a good environment if you want to interact with the Google Cloud Platform. It's a building Cloud Shell, building shell function, and it's like a building terminal. So you can give your command there and deploy everything, just very easy to use. A lot of integration already being connecting here. So looks like we already got it. And the first thing I'm gonna do is I'm gonna change a little bit of my code. So I am going to go into my code. And because I see a lot of user feedback that, oh, this sign guestbook button is really ugly. It's not intriguing. It's not, people don't want to click this. So to improve this, I want to change the color of the button so it will be more, people will like to interact with it more. So what I would do is I want to change a little bit about this button, and what I can do is I go to my code and then I can find this line right here. So as you can see, I'm using Bootstrap, and this is the, zoom in a little bit. This is the button class I use, so I'm just modify it. I want to be more catchy, so I want to change it to red. So it's a button, I change it to red. Okay, the next thing, since I already finished my modification, the next thing I want to do is I want to deploy again. I want to deploy my application to my environment. So how do I do that? Remember the line? G-Cloud app deploy, right? So it's pretty easy. So I just click here and I give in the version because I already have one version here, and I will just give in another parameter, which is version 2. Let's say click create, click enter. So here, as you can see, App Engine already pick up the changes my code and upload into a cloud storage, as you can see here. And once it's done, it will be shipped directly to my front end. So I will just remove this so we can see the version. All right, just give it a moment for it to finish. All right, looks like it's already been deployed. Let's take a look at the dashboard again. So as you can see, this is the original application I have. If I go to the version, I should be able to see 2 versions, right? So here I have 1 version, I have previous version. If I go click into my version 1, it's still the blue button is still here. But if I go to the button 2, version 2, then you can see this is the fascinating, amazing red button I want. So it's not the end, Next thing is that I just don't want to create something that just only I like it. I want to test it out to the user, so I can get more feedback from the user. How do I do that in App Engine? So in App Engine, you can actually easily split traffic between the version. So how do you do that? So if I click here, there's a split traffic function, And I can just specify how do you want to split the traffic. You can depends on the IP address, depends on the cookie, or depends on just randomly assigned. Because for demo purpose, I'm going to just randomly split my traffic from the version 1 and the version 2, which is the blue button and the red button here. So I'm just click 50-50 here, and then click Save. Just giving some time, now the App Engine is configuring the traffic. So, well, if I go into it again, I might see different result, depends on the traffic. So see, I already finished the configuration. So if I jump back, I go to my same URL again, which is here. So this time, I will be able to see different results, right? Because I just give it a random access from the blue button to a red button. So if I just keep refreshing my page, as you can see, sometimes you will see it red, sometimes you will see it blue, because I just randomly assign them based on 50-50. So the red button is my version 2, blue button is my version 1. So you can see, you can simply do that. So just quick check here. Now the Q&A session is going to end soon. So if you haven't done the Q&A, please do it now. Thank you so much. So I'm just switching back to my slides here. So as you can see, just wrap out a little bit, App Engine really let you to deploy your application super fast. As you can see, I'm just using 3 words, G-Cloud app deploy, give you a version, and ready to go. And it's just very easy to play around, to test it out, your application, and receiving feedbacks. The final section of this module, I'm going to talk about Cloud Run. What is Cloud Run? Before we talk about Cloud Run, let's talk a little bit about serverless. Serverless is, you can think of it as 2 ways. First, it's from the operational perspective. Serverless manages the underlying server for you, so you can focus on the developing application more. And instead of exposing, you need to expose your image of your machine directly to the world. Serverless actually give you a trail layer for your security purposes, including those firewall settings or network protection as well. Finally, when we think about serverless, it allows us to only pay of what we use. You do not, it's not only save your time and effort, but also save your money. For programmers, what we think about serverless are these ways. First, we think about how you can modularize your application. You can think about server-based or server-oriented infrastructure. And think about event-driven. You can separate those infrastructure into each piece of events and then handle it one by one and using message queue to connecting together. Finally, you think about open. As a developer, I always need to learn a lot of new technology. So I really hope that the technology I learn is like open source, and people in the other platform, other industry also using the same technology. So these are some concerns to explain what is the serverless. What about containers? I've talked about it. Actually, it's a place for you to host your application that is written in any language, any libraries, or using any binary, etc. And container is getting really popular. People are starting to learn about what is container and starting to adopting those containers. As you can see the trend here. So let's bring to my topic in this session. What is Cloud Run? In a nutshell, it brings the serverless to containers. So you can use container, but use it in a serverless way. There are 2 options for you, from using Cloud Run. First is the fully managed service. You only need to focus on your code, and you don't need to create any cluster, and you only pay per use. The other option here is called Cloud Run for Anthos. So this Cloud Run for Anthos actually allows you to run your container image on Google platform and also on the other platforms such as on-premises and AWS, because Anthos is the technology in Google Cloud that allows you to manage Kubernetes cluster no matter where it locates. So there are two options. You can either use the fully managed one, or you can deploy your application, let's say, to different environments or different cloud environment as well. There are some features you can, use. You only pay what you use, and the granularity can be nearly 100 milliseconds. And in some cases, you can put it as a public website, or you can use it as a private microservice infrastructure. How do you compare between these options? First, if your job is fully serverless and it's more event-driven, you should consider using Cloud Function. Second, if you really want to ship something really fast and you don't have much of operation staff with you, you can consider using App Engine, because this allows you to only focus on your code and you take care of the rest for you. The next option is that you already containerize your app and you also want to leverage the serverless benefits of the cloud platform. You can use in Cloud Run, because that will help you to ship your container and then run it smoothly on the cloud. So let's take a look at my final demo of the day. I'll just jump quickly to my environment here. So this is what it looked like in the Google Cloud Platform. So here I'm just quickly create a service, and you will notice how fast it is to deploy a container. So I'm just choose a region in Asia Pacific. There are two options, as you can see here. The first is fully managed one, the other is Anthos one. So here in the fully managed, I'm going to give you a name. In this demo, I'm going to show you a PDF container. So this job is actually, you will convert the PDF file from a Word document into a PDF for you. So you don't need to rewrite that again. Sorry, let me type in the... All right. Let's click Create. So as we speak here, you can see the Cloud Run already start picking up the container image, and then setting up those servers, those YAML file. As you can see, I didn't create anything. I didn't create any YAML file. I didn't create any infrastructure in advance. And it just runs smoothly, and it's so fast, within the seconds, it just returned to me. And I just take a look at what the application looked like. So as you can see, this is the Docker image I just give the I just sent out, and this is the application that can help me convert my Word document into a PDF. So here I'm gonna do is I'm gonna give this application upload a Word documents. As you can see, this is a docx format, and click upload. So now the container actually processed the Word document and then convert it into a PDF. Well, okay, so we already got it back super fast, right? So now let me explain a little bit about how it is written. So here we have two files. The first, this application is a simple Python application. As you can see here, this will help me handle the HTTP traffic. And also, the job I do here is I code a OpenOffice library, as you can see here, to convert the Word document into PDF. How does it work? I use a simple Python image, and then I just run an OpenOffice library here. This is a very old, piece of code, but it runs smoothly in container, and that's the beauty of container. And as you can see, it can be really quickly to deploy this container and run it smoothly on the environment that we provided. So the next demo, I'm going to show you what it looks like to deploy into cluster. So let's say I've already have a Kubernetes cluster in place, and I don't want to use a fully managed one because I want to have more control of my cluster. Let's say I can click this one is the cluster I already created, and I'll give it a service name. In this case, I'm just giving it a pdf.cluster. Okay, and then click Create. same URL. Service. All right. So just give in some time that while we speak, you're already picking up the same image. But different is that instead of pushing it to a fully managed one, it actually deployed into a container, a Kubernetes cluster that we already created before. That's wrap up for these sections. So what is Cloud Run? Basically, this helps you to give you the ability to run your container wherever you like. And no more, you can just focus on your code only. You don't need to focus more on the service management. And it can be very scalable. You can scale very fast, up and down, or even scale to 0 if there's no traffic. And lastly, because it leverages the container, so you can be written in any language, and you can be easily deployed to the fully managed Cloud Run and the Cloud Run that located in your Kubernetes clusters. So that's it for this module. Thank you so much. We look like we have Q&A already in place. Let's take a look at some questions. We have 2 questions here. The first question is, which GCP service can facilitate the implementation of CI/CD workflow? So I've listed out some service like Cloud Builder, Container Registry. Sorry, Container Builder actually remained to Cloud Build. And the third one is source code repository. We have amazing results. 65% of people are answering right, so amazing. The second one is cloud events are things that happen within your cloud environments that you might want to take action on. Cloud function support events from the following providers, or which following provider you can deal with by a cloud function. So the answer is Cloud pops up, and HTTP requests and cloud storage. We have around 1/3 of people answering right. So that's it. Thank you so much. That's the end of this module. Really appreciating for participating. Hope you learn as well as I do, and hope you enjoy the rest of the session. Thank you so much.